All right, everyone. Thank you for coming today. I know it's the afternoon. It's been a long day for a lot of folks in this room, but we are very excited to talk about CI/CD, Kubernetes, and databases, and why we strongly believe they're definitely better together. In terms of just a quick round of introductions for us, I'm Niraj Tolia. I'm the co-founder at Kasten. We are a startup based in the Bay Area. We really look at data management for all your cloud-native applications, everything from backup and recovery to some of the things we're going to talk about in this talk. But personally, I've been working on data and storage systems for a long time. In reverse chronological order, I was at EMC, responsible for the Cloud Boost family of products, Magnetics, where we did distributed file systems, next generation storage class memories at HP, and before that at Carnegie Mellon, where I did my PhD on distributed storage systems. I'll let Tom introduce himself next.
Hi, everyone. My name is Tom. Prior to Kasten, I was at Dropbox, where I worked on the database service layer. We managed one of the largest clusters of MySQL in the world. Before that, I was with Niraj at EMC, and before that, Magnetics, before it was acquired.
All right. Thanks, Tom. So the high-level goal behind a lot of work we do and what we're going to talk about today is how you can move fast but without breaking things. And in particular, test with real data at different stages of your pipeline and some of the benefits that come about from that. If there's one thing I want you to take away from this talk is that this is something that will be very valuable for you and it'll give you a number of benefits, but more importantly, it's not that hard to do as you might think. There are a few things that we will not cover in this talk today. Some people sometimes have doubts about whether Kubernetes is ready for production stateful apps. We definitely believe it is. We had a talk earlier this year at SNIA's Storage Developer Conference. I encourage you to check that out. And secondly, we're mostly going to be talking about data usage in pre-production stages of your pipeline. If you're looking for more information on how to manage and protect your data in your production settings, go for our talk tomorrow at 2:35 p.m. Right? That should be equally interesting too. Yep. So to jump into the contents of the talk, right? Really, when we go look at databases in terms of how people are using them in a cloud-native world, sometimes people believe that is fine. But from our perspective, right, we believe there's a large gap between where we are today and where I think we should be for things that we care about, which is at the end the application and delivering value from those apps. But before we jump into how to get to a much better state in the world, it's good to ask ourselves, why is there fear and risk in some of these environments? Why people are concerned about bringing databases into your pipeline, testing with data, things of that sort. And some of it is because of the reasons you see on screen. Databases have traditionally been snowflakes, more pets versus cattle, if you're familiar with that analogy. And they would sit off on the side somewhere outside of your application clusters, potentially even manual changes applied to them, which led to a lot of risk in terms of making changes to that. It's also been significant automation gaps is what we've discovered with our customers. They're not built in early into your CI/CD pipeline. Testing might happen with synthetic data or data that could be stale multiple months out of date. And finally, it's not about always a technical issue. I mean, with the DevOps shift, we are seeing developer and operations definitely coming closer together, but we still sometimes see database engineering somewhat sitting off on the side. And this is another silo we need to break down and to bring it in into earlier stages of any CI/CD pipeline you bring up to reduce all this risk and fear that we're talking about. In terms of what we believe that the future should look like, right? At the very high level, it is simple. You want to keep calm and automate as much as you feasibly can. But more concretely, we believe that to increase agility with databases in your cloud-native environment revolves around three things. The first one is source control. Now, this is common for a lot of our application code, but there are a couple of important things to note as to what we propose you all do. First of all, include all schema changes, any upgrade tools you use, modifications, et cetera, into a source control system, but not just any source control system. You want this to be tightly integrated with the application code that the database is serving. Now, it's not just about schemas, it's also about infrastructure, where you want your database infrastructure to be expressed as code again, configuration, things of that nature, and put it into the same source control repository. And finally, you want to build this not just into your CI/CD pipeline, but as early as possible. So you automate all your database changes, testing, as your application development happens. And finally, in case you missed the subtle icon in the middle of this atom, we really believe that you should use Kubernetes to tie it all together. Now, at this point, you might ask me, hey, Niraj, right, all of this is great, this is fine, but wouldn't this also equally apply to any legacy environment, whether I be running on VMs or bare metal? And the short answer to that is yes, right? This applies across a variety of environments. But given the advantages that Kubernetes provides us, I think it would be foolish for all of us to not explore how we can leverage that. In particular, because of the reasons you see on screen. Kubernetes by itself will enforce good DevOps hygiene. The immutability aspect of things ensures you will move away from snowflakes in your infrastructure. The fact that you're expressing configuration and infrastructure as code will make automation and testing simple, reliable, and easy for you. In large-scale testing environments, it's also much better from the cost and efficiency perspective. If you're giving developers their own individual copy of databases in these environments, it's much better in terms of bin packing that you can do compared to spinning up, say, for example, managed services individually for a developer there. And finally, as a number of customers have told us, it is also about making sure you have a universal control plane. In the long term, it doesn't make too much sense for you to have a separate control plane for your database services and then one for the stateless components of your application. It'll make a lot of sense to combine these all within Kubernetes itself to give you better efficiency in your environments. Now, just popping up a level, just looking at CI/CD advantages, there's a dev test deployment loop that we have there. And the reason why people have picked platforms such as Kubernetes today is to ensure we can tighten this, make it faster, deliver better value to whoever our end customer might be. Integrating databases into this will obviously give you automated testing at every stage, but more importantly, it'll lead to higher confidence because things won't just come together in production, but much earlier than that, which will naturally lead to better engineering agility. So a faster change iteration process will over time lead to better and faster deployments to production versus sometimes bunching changes together to do it only on a periodic basis to a database infrastructure. And you will catch issues early where, say, for example, if you're testing with synthetic data, which might fail over in production, or in a situation where code that works well with small data sets might not work with large ones. So things of that sort will be very beneficial as you go along. However, right, we've talked about a number of things here, and all of that's great. But really, we're talking about databases. And really, databases are covered, NoSQL systems, relational databases, all of those under that umbrella here. But we haven't spoken about data so far, which is an essential component just of the term itself. And how do we handle that is something people have struggled with traditionally. And our belief is that, to again, get the full advantage that we believe you should have, you want to test with production data. But you do not want to do this in production. I think people that say, hey, go test in production are crazy people. You definitely don't want to do this with precious data that your application or your enterprise depends on, which leads, because of issues such as sensitive data, you don't want to expose to developers, you don't want to accidentally corrupt data running in your production environment. But then how do you do this safely and efficiently becomes a question for all of us. And in particular, to get to an ideal state of the world, you're going to need to integrate against different layers in the stack for efficiency reasons. First of all, you probably will need some storage integration. When you're talking about integrating with volume-level snapshots on copy and write file systems, it's great when you have large data sets. Better efficiency will result from that to say, hey, take a snapshot, move that into my test dev environment. But you can't just stop there. You really need to think broader than that because you want your hooks into your NoSQL system or your relational database for consistency reasons. When you're capturing data, maybe you want to quiesce your database before you do a volume-level snapshot. You might want to ensure that in an eventually consistent system, you have a way to extract consistent data out of that. So those are some of the issues that come up at the database level. And then finally, when you go look at application integration, right, we see a wide spectrum of applications being deployed, whether you talk about Kubernetes, OpenShift, Cloud Foundry, things of that nature. But polyglot persistence shows up over and over again in some of the microservice-based applications we see. So if you're not familiar with that term, what that essentially means is that you're using, within the context of a single application, you're using multiple best-of-breed data services for what you want to do. So we'll often see a relational database with something like Mongo, with potentially Redis as a cache on the side, all in the context of the same app. And how do you extract data from that in a consistent manner? Needs application context. Further, when you go look at some more advanced topics, when you're masking data, encrypting data before you move it into test dev environments, you again need that application context to figure out how to do some of these things. Now, while some of these might sound like significant challenges, I'm going to next switch over to Tom to talk about how you can easily do these things in the context of your environment today.
Thank you. So Niraj just described a set of challenges associated with something we refer to as data mobility. When using data mobility to improve your CI/CD pipeline, it's important to consider the data at different layers in your application stack. In fact, in many instances, it's important to perform operations on multiple layers of your application at once, as well as interact with Kubernetes itself. So we've released a project called Canister to help address these challenges. Canister is a fully open source framework whose goal is to address data mobility challenges inside Kubernetes. It's easy to integrate with your CI/CD pipeline because it uses Kubernetes API extensions called custom resources. And so you can invoke it, for example, by using kubectl. You can easily extend it to work with your custom application, but we also have integrations for several of the common databases that we've seen in a cloud-native context. Canister supports a lot of features. So it supports file, block, and object storage. You can push and pull to object storage. If your application is built using PVCs, and that's how it consumes its file and block storage, then it can integrate with Canister. We look forward to more providers implementing CSI or the container storage interface. Right now, we invoke library calls of different providers directly for things like snapshotting and copying volumes. However, as more providers implement the CSI, we'll move over to those implementations. Many features in data mobility have to happen at the database level. So things around security and performance are enabled through Canister. The specific features that we're talking about are things like filtering, masking, and incremental backups. Many data mobility features require coordination with your application's lifecycle. Canister supports this by providing library functions for things like kubeexec, as well as modifying the spec of your resources so that you can take Kubernetes actions. Excuse me. To just give a brief walkthrough of how Canister works, let's say that you have a Kubernetes cluster, and in that cluster you have your stateful application. You've installed Canister, the Canister controller, and you have a blueprint. The blueprint is specific to your application, and we have example ones, but you can also build your own. So in order to initiate a Canister action, you first create an action set, for example, by using kubectl. The action set will get picked up by the controller. It will then go look up in the blueprint to see what the implementation of that specific action is, and it will go execute whatever is specified in that blueprint. In this case, if we do a kubeexec, we'll be running some commands inside the containers of our stateful application. Finally, we will update the status of the action set so you can see what happened with your action. To dig a little deeper to see what an action set and a blueprint look like. So an action set itself is a Kubernetes object. It's a Kubernetes custom resource, so it's an extension, meaning it has all the same metadata as the Kubernetes API objects you're used to. So it has API version and kind, for example. This action set, we're choosing to do an action called backup. I'll get to that in a second. We're working with a blueprint called Postgres. And we're working on a specific stateful set inside of our application. We've also included configuration through config maps and secrets. So if we look at the corresponding blueprint, it itself is also a custom resource, meaning it has the same metadata as an action set as well as the other Kubernetes API objects. In this case, we're implementing the action backup. Backup works on a stateful set, and we'll be doing the kubeexec to run inside a container. The arguments to blueprints are templated, so you can pass in, you have access to information like pods and services for the stateful set. In this case, we're going to be running a Postgres-specific tool, in this case Wally, to take the backup of our database. And of course, make sure if you implement backup, you should also implement restore for that action. Now I want to show you what this looks like in action, especially in a CI/CD context. For a demo, we've implemented a CI/CD pipeline. We've stored our applications configuration, code, and database schemas inside of GitHub, our source control. Every time we push a new commit to GitHub, CI will trigger integration tests on some data sets. When that passes, then we can finally merge into master. Our deployment pipeline will then push that new code to our production cluster. But what's really interesting for the context of this talk is that we'll pull data from production for use inside our integration tests. So we'll be using the most recent data that we have, and hopefully we'll discover any issues that we would otherwise hit in production. To dig in even deeper and to see what this data movement looks like, we have this setup. So there are two clusters. The cluster on the left is our production cluster. It includes our application and database. The cluster on the right is just our integration test cluster. In both clusters, we installed K10 and Canister. K10 is a commercial product whose goal is to help manage stateful applications, often by invoking Canister for its data mobility. We've created a policy which will tell K10 to snapshot and then export this application. A snapshot creates something we call a restore point, which is a collection of configuration and data. And then we export that restore point into some public cloud, or some object store, rather. The object store will contain both data, but also references to data in the case of things like cloud provider volume snapshots. In the integration cluster, we'll periodically import these restore points so that they can be made available to restore. When a test runs as part of CI, we will create a new namespace with a new app and a new database instance. And then we'll trigger a restore action to populate that database. Finally, the database will be populated with the original production data, and we can run our integration tests against this cluster. So now I'm going to actually switch over to a demo. This demo is recorded, obviously.
Hold on. It's not up there.
Oh.
Give me a second. Sorry.
I said we should have used Linux, but.
Okay. Hold on.
Cool, thank you.
Give me 1 second. It's going to be easier. There we go.
Thank you. So here we have an application that we've developed just for this demo. Our application's goal is to just simply record orders and store the zip code for each of those orders. It's relatively simple. We can look at what is contained in the application. So there's a web server, which is hosting our web content, and then a database for storing our data. The database has a PVC. We can actually log into this, and we'll port forward there. And we can see what the content of our production cluster is. So we have a bunch of zip codes here for each order. And if we want to, we can even add a new zip code. So I'm adding 90210 here. So now I'll show the setup we have for K10, and specifically our policies that we've set up to export and import data. We've created a policy which will periodically, every hour, snapshot our full application, and then we'll export that snapshot. We've configured this to use S3 and to use this bucket. Similarly, we have a test cluster, which has a similar looking policy, but for import, and it's configured to use the same bucket to import the data. Okay, great. So now I want to show you a new feature we've been working on. So this new feature I have running in my test cluster, and I'll expose the port. So this feature groups all of our orders by zip code and by city. So you can see all the cities where we have different orders, which is great. Okay, I think that looks good. Now let's run some tests. So I'm going to connect to the running database to run our tests. And now I can run our unit tests. Okay, great, that passed. So I think I'm ready to push this to GitHub. Let's check to see what the changes are. So here, basically, I've just enabled this feature, and I've enabled the test. Okay, I go through my Git workflow. I check out a new branch. I commit all my changes. And now I push to GitHub. Now from here, I can begin to create a PR. I go find the branch I just pushed and open a pull request. I can quickly double check to make sure that the changes that I push are intended. They look good. And now I can create the PR. So this is the part in the demo that we fast forwarded because we didn't want to make you wait for our CI test to run, especially because these are integration tests. What's going to happen is the full workflow that I showed before, where we restore production data into a cluster and then test against it. So we jump ahead, and it looks like it failed, which is usually a bad thing, but in this case it's actually good. So our integration test caught a real issue with our code. It turns out that we were expecting only a 5-digit format for our zip codes. In this case, our production data had some 9-digit zip codes, which we can see here. So this failure is meant to demonstrate that you can catch issues by using real production data in your integration tests. And then this protected our production clusters. Sorry, I don't know the Mac shortcuts. So there are many things we didn't get to cover in this talk, and they're listed here. Schema changes are always very dangerous, and so it's important to build proper test infrastructure around them to make sure that they're safe. In this talk, we talked a lot about using databases inside Kubernetes, but managed services can also benefit from the same testing techniques that we showed. We barely scratched the surface with masking and sampling, but it's also a great way to make sure that your insensitive data is safe, and also that you can perform efficient data mobility actions. In this talk, we showed moving data from production into test. However, there's also cases you can make for moving data from test into production, for example, machine learning. And so to conclude, we hope that you'll build test infrastructure around your databases. We hope that you'll leverage Kubernetes for your test infrastructure. We hope that you'll use real data to help expose issues that will only arise in production otherwise. And finally, we hope that you'll combine all these things to make sure that your database engineering is agile. So please reach out to us. We love to chat, especially to hear about your stateful applications in Kubernetes. And with that, we'll take some questions. Thank you. That's a great question. So the question was, what if you're using something like RDS for your production data? Is there a way that you can still use the same techniques? And the answer is absolutely yes. For something like RDS, there's really two ways that you can do copies of your data for testing. So one way is by using the cloud APIs. You can do an RDS copy of your data and then use that. The other way is doing a MySQL level copy. So you can do a MySQL dump and then use that data for your testing. Great question. So you're asking all the advanced topics, which is awesome. So the question was, for GDPR, can you scrub PII from your data, essentially, right? And the answer is yes. You have to do it, but you have to do it at the database level, right? You have to introspect to see, fields that you cannot use for your testing pipeline. And so we essentially provide the framework so you're able to do that. And we'd love to hear about your specific use case kind of offline.
So just to clarify, in the blueprint Tom had shown earlier, right, as a part of the data capture step there are multiple phases possible that you can have in an order. So once you've captured data, you can either encrypt an entire column out, completely mask it, fill it with random data, whatever you choose to do. And so there is actually deeper functionality in Canister that allows you to spin up a sandbox copy of the database, mask that data, and then push it out into an object store as an example. Yeah. Sure, go ahead.
How would you modify this approach to large data sets without sacrificing velocity that you can't pare down so that you can push it around?
Great question. So the question was, if you have a really large data set and you want to use that in your test infrastructure, so one of the things, again, advanced topics we didn't mention was sampling. And so you could reduce your data set on import so that you would still be able to test with it very quickly.
And if you can't reduce it, is there a way to modify this sort of model?
If you can do some kind of like copy on write, or if you can make sure that you will not be impacting production but still be testing with production data, that's kind of the only way to do that, I think, unless you have more.
No, I think Tom covered it, that ultimately, right, data will have gravity and the fundamental limits to what someone can do. If you can't downsample, as an example, the best thing is to evaluate the storage system of choice. So you can have copy and write snapshots underneath. So it's easy to do copy data management for your test dev clusters.
So you'd be sacrificing freshness.
Potentially, maybe not even freshness. If there's no masking step involved, freshness will not get impacted because you can do this on a very regular basis. Hopefully they'll be cheap, almost zero cost copy and write snapshots. But right, we can dig into this offline as to what your environment might look like. And yeah. Mm-hmm. Any other questions?
How does K10 compare to the AWS data pipeline?
Okay. So, all right. So it's a great question. So a couple of things. K10 was used here just for ease of illustration for demo. You actually don't need K10 to do any of the things that we showed today. You can do it all within Kubernetes natively itself. Now, when you compare about AWS data pipeline, it's not so much, it's not really a direct competitor there, but the way to look at it is Canister would compare a little bit more to AWS data pipeline, but it is cross-platform no matter where you're running, spanning managed services, on-prem, et cetera, that's where it would fit in. Okay. Anything else? Going once? Going twice? Thank you very much. Really appreciate your time today.